Okay, waiting for the streams to catch up with me. Audio sounds good. You can quickly check audio on the other end. That sounds good. Okay, now we're just waiting for YouTube, which is always the slowest for reasons that are unknown to me. So I should make weird sounds. All right, looks like we are go. Good morning, everybody. Well, morning for me. I suppose it could be different times of day for y'all. We are starting a new paper in the Kaggle Reading Club, and as usual, I opened up to a vote. And I remember the last one, it was XLNet and the one that we actually read, and I definitely remember the name of that paper. Hi, Nicholas. Yay! This is a good time to make it to the live stream because we're starting a new paper. Well, whatever paper we read last time won by one vote. Sparse Transformers, that was the one. No, it was the one after Sparse Transformers. Anyway, we've read so many papers, they start to blur together a little bit. This time there was no contest. XLNet handily beat out all of the other papers. So a little bit of information about XLNet. I don't actually know that much about it, except that it's autoregressive, obviously, from the title. And I'm mostly familiar with autoregression from time series, and the basic idea is that you do regression on time point n based on time points n-1, etc. So you're regressing on previous points in the time series, and I think they can be used in other ways, but that's the only place I've run into them personally. And this is quite an interesting assortment of folks. So some of them are from Carnegie Mellon, CMU, which I think is in Pittsburgh. It's well known as a machine learning sort of computational science university. I think they also have a really good robotics program. And also Google Brain. And unless I'm mistaken, I think at least one of these researchers is from Apple AI right now, or they have transferred to Apple AI, because I was looking up all of the authors to tweet about it, and one of them had a bio that said that they were from Apple, and I think it was, I'm just going to pull up the tweet here. So here's the tweet. No... Yeah. So Rush Salakhutdinov? I probably got that wrong, and that's on me. I'm sorry about that. Is also at Apple, which is interesting because you don't see Apple generally publishing a lot of papers, and this may be a little bit of a sea change there, so that would be exciting. And then Kwakla, who actually I did an interview with a little bit ago. We talked about AutoML and neural architecture search. So from people that I am more or less familiar with, I don't think I know Shulin Yang or Yiming Yang, Jamie Carbonell. Sounds a little bit familiar. Anyway, that's the things that I know about the paper. That's pretty much it. Oh, the other thing I know about the paper, which I think is the important thing that people have probably heard about, is that it is currently state of the art. So in this paper, they lay out results that are better than the ones laid out by Bert, which we read like 3 papers ago, and Bert is an architecture that does language modeling using bidirectional transformers. And if you remember the basic idea is that there's it's trained on a task where you have a sentence and you mask one word in the sentence and you guess that word in the sentence instead of modeling the conditional probabilities between every word pair or triplet or whatever, which was sort of like the more usual way of doing language modeling prior. All right. Hello. I'm seeing so many people. Manji, Andrew, David, Andrew. That's how that name is usually said. Ralph made it to the live stream. Welcome. And Knuxel, hello. Welcome, everybody. And with that out of the way, let's jump in. So I did put the link in the bio this time, not the bio, the description. So if you want to read along, you're very welcome. And I will also make it bigger. All right, abstract. With the capability of modeling bidirectional context, denoising auto-encoding based pre-training like Bert achieves better performance than pre-training approaches based on autoregressive language modeling. Denoising, okay, presumably we will talk about all of these things in the future. However, relying on corrupting the input with mask, Bert neglects dependency between the masked positions and suffers from a pre-trained fine-tuned discrepancy. Okay, so the mask is the thing where you are looking at the sentence except for one of the words, which is hidden. Bert neglects dependency between the masked positions. So they're saying that because there's a mask there, the things that you have masked, you can't model their relationship to each other, which means that when you take the existing model and apply it to a new problem, you get different outputs, I guess. Let's see. Sorry, I saw some comments go by. Is this model launched by Microsoft better than Bert? I know there have been some Microsoft models. I think Big Bird was a Microsoft model. Excuse me, sorry. This one is out of Carnegie Mellon and Google. Yeah, Andrew says 2 masks. I'm assuming what they mean here is when you are training over successive sentences, you'll see different things being masked. But yeah, I think that generally during training they were only masking one thing per sentence. This is the abstract, so hopefully everything that they say here they'll go into deeper detail in a little bit later on. In light of these pros and cons, we propose XLNet, a generalized autoregressive pre-training model. So autoregressive rather than auto-encoding. That one enables learning bidirectional contexts by maximizing the expected likelihood over all permutations of the factorization order. What? Enables learning bidirectional contexts, we're looking both ways, by maximizing the expected likelihood. So we want the MLE, which is very common in statistics, over all permutations of the factorization order. All permutations, so all possible combinations. What's the factorization order? I don't know what the factorization order is. And 2, overcomes the limitations of Bert thanks to its autoregressive formulation. So I think they're claiming here that the model works equally well on its training data and unseen data. Furthermore, XLNet integrates ideas from Transformer XL, the state-of-the-art autoregressive model, into pre-training. Empirically, XLNet outperforms Bert on 20 tasks, often by a large margin, and achieves state-of-the-art results on 18 tasks, including question answering, natural language inference, sentiment analysis, and document ranking. Andrew said, do they mean dependency between 2 masks in the train case? I think they must. Yeah, I'm hoping they'll go into more detail there because I am a little confused. Renato says, the new model from Microsoft is called MTDNN. Yeah, I think that was actually an option for one of the papers at some point in the voting in the past. I haven't read it. Or if I have, I've forgotten all about it, which, both equally likely. And me and Gustav are both doing very well. Gustav is my hedgehog, and he has a vet visit next week, so hopefully that goes well. Okay. So they're saying that as opposed to Bert, they can handle... Oh, one sec. Sorry. I want to make sure you guys don't hear that little bit of echo. So as opposed to Bert, they can handle... No, I think they can handle the same data. Sorry, I'm trying to pick out the differences between the models. So they're saying that they're autoregressive rather than auto-encoding. And that this means that they can perform better between the pre-training and fine-tuning, so that those are more similar to each other, performance on those. Okay, that's what I'm getting so far from this. And then, of course, they get state-of-the-art, blah, blah, blah. Otherwise, people would not be talking about the paper. Andrew says, perhaps this is an example generative output, not an abstract. No, I think it is an abstract. This is also a fairly machine learning-y group of folks, I think. I don't know how many of these people predominantly work in natural language processing and with language data. I'm not super familiar with any of them except Kaggle, and I know that he predominantly works on like very core machine learning, auto machine learning thing. Ryan says, we read MTDNN. Yeah, we read it on the channel. Oh, is it the one with the gated, not gated RNNs, but like gated CNNs? I vaguely remember. Multitask learning. Oh yeah, we definitely read that. Okay, so that's the one where you're learning multiple tasks and the errors on each of those tasks propagates back through the same model. Okay, all coming back to me. This is not coffee and it's not caffeinated, so we'll see how I do. Thanks, Ryan. Yes, we did read that. Okay, introduction. Oh, this is nice. It doesn't have 2 columns, which is another, generally ACL papers tend to have 2 columns, and this is much more of a ICML-y type of format, which is another giveaway that maybe these are machine learning researchers and not so much NLP researchers, which is fine. It's nice to have, cross pollination. Alekin says, so the autoregressive bit introduces some kind of correlation between the masked positions. We'll find out. Introduction. Unsupervised representation learning has been highly successful in the domain of natural language processing. I hate this citation style. I hate it. I want to see the names and the years in the text. That is important information that I need to know for me and my scholarship. Hate it. With a fiery passion. The only place I think it's acceptable is on a poster, because then you're on the same page and you can just look down in the corner. That is my personal huge pet peeve. But I think it is, again, ICML style, so. All right, well, I'm assuming that they're going to cite, like, the important ones here, and I can't see what they are on ClickOver, so deep contextualized word representations. I don't know if we read that. That one's out of Allen NLP, and now I'm going to have to scroll back up. Oh, like, if you're going to do this, at least don't alphabetize your citations so that I can, like, look at a bunch of them in one go. And then not even in order. Okay, well, you guys can look at those citations on your own time. Typically, these methods first pre-train neural networks on large-scale, unlabeled text corpora, and then fine-tune the models on representations of downstream tasks. Yeah, we've seen a lot of that. Sorry for ranting. I'll try and keep it a little bit more. No, I'm not going to. If something bothers me that much, I'm just going to let you know. Yeah. Under this shared high-level idea, different unsupervised pre-training objectives have been explored in literature. The literature? Explored in literature says to me that they are talking about this being explored in, like, literary fiction, which I think is not what they mean. So there are different ways to do the pre-training or language modeling. Back in the day, it was all sort of like statistical, n-gram sort of based stuff. Recently, people have been trying different things. Among them, autoregressive language modeling and autoencoding have been the 2 most successful pre-training objectives. Autoregressive language modeling seeks to estimate the probability distribution of a text corpus with an autoregressive model. Specifically, given a text sequence x equals x1 through xt, autoregressive language modeling factorizes the likelihood into a forward product. Factorizes the likelihood into a forward product. Okay. P of x is the sum of probabilities of the probability of xt given x less than t or a backward one. Okay, so we are looking at each word in our sequence, and we are calculating its probability given previous words in the sequence or given further words in the sequence. Oh, this is just normal language modeling. I don't think I've ever heard it called autoregressive language modeling. Okay, this is exactly what I think of when people say language modeling. My feet are under me again. I understand things. I'm good to go. Product of probabilities. Yeah. Sorry, did I say some? Definitely product. Thank you for the correction. Okay. A parametric model, e.g. a neural network, that's a weird thing to call a parametric model, given that we're in probability space, is trained to model each conditional distribution. Okay, so we're given each conditional distribution would be a distribution across the vocabulary for each word in our vocabulary. Since an AR autoregressive language model is only trained to encode unidirectional context, either forward or backwards, it is not effective at modeling deep bidirectional contexts. On the contrary, downstream language understanding tasks often require bidirectional context information. This results in a gap between AR language modeling and effective pre-training. Yair says, the autoregressive term is more frequent in time series analysis, I think. Yeah, that's where I've heard it before. But I guess that makes sense because you're modeling the probability of a word at time point t given the words at time points before t. I was going to try and do it with numbers, and I didn't start at 1, so it's a little bit hard to say with word good. Okay, and they're saying that this is really good at going one direction or the other direction, but it's a little bit more difficult to go in both directions, which is why people have done things like Elmo, where you train one model forward, one model backward, and look at them together, or done things like Bert, where you're looking forward and backwards at the same time, given the point that you've masked, the word that you've masked, where words are points, I guess. Okay, I am, Yeah. Okay, so this makes a lot more sense. I think this is just like vocabulary that I wouldn't use to describe these particular things, but now that I'm on the same page, this makes a lot of sense. In comparison, AE, autoencoder-based pre-training, does not perform explicit density estimation, but instead aims to reconstruct the original data from corrupted input. A notable example is Bert, which has been the state-of-the-art pre-training approach. Given the input token sequence, a certain portion of tokens are replaced by a special symbol, mask, and the model is trained to recover the original tokens from the corrupted version. Since density estimation is not part of the objective, Bert is allowed to utilize bidirectional context for reconstruction. Sorry, I'm trying to think about whether the fact that Bert isn't doing density estimation is what allows it to be bidirectional? I guess, because you don't need to be sort of like looking at change over time. Santosh says, I think autoregressive models are used to convert joint distribution into a conditional distribution. Oh, that makes sense as well. So it's not just co-occurrence, it's, more linear. It loses complete sense when you use it in both directions, though. This is a rewrite of Elmo. Oh, and Nicholas says, what does density estimation mean? So I think of it, and it's been a minute since I've had statistics, I think of it as a probability distribution over a set of things. So feel free to jump into the chat and correct me here, but I think of it like if it's sunny today and it was sunny yesterday, can I use that to determine how likely different weather patterns are tomorrow? So will it be sunny? Will it be cloudy? Will it be rainy? Given the information that I have, where am I going to sort of like put the bulk of my probability points, if that makes sense? Yeah, so in a language modeling context, that would be like if I say I'm going to the blank, and then I have my whole vocabulary, I'm going to assign probability points to things like, you know, store, park, school, ball game, or like all vocabulary words that have occurred in similar positions in my training corpus. Nicholas says, is it like conditional probabilities? Yes. But over like a set of contexts. I think that's my understanding right now. And again, not a statistics professor. So if y'all have different understandings, I would appreciate more, collaborative. Yer says, sounds pretty right to me. Okay, good. Also, all of my like understanding of statistics is just like, you know, like those like toys that are a bunch of nails and then they're between like plexiglass and you like put your hand into it and like the handprint shows up. You put your face into it and your face shows up. It's like that, but it's numbers and like things possibly happening. I don't know. I don't know why that's how I conceptualize statistics, but it is. Andrew says, I think you got it right. Thank you. Helpful. Anything that is approaching it as, what's the most probable thing unknown given what I do know? Yeah. That also sounds right to me. All right. Blah, 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 blah. So we were talking about Bert. Everything's available online, which I think the Kaggle community knew because a lot of people use that in the competition that recently closed. Equal contribution. Okay, so the first two authors contributed equally, which is nice. They're both first author. Orders determined by swapping the 1 in 9. Okay, so there must be another paper where they both had equal contributions and they're just doing it with the opposite order here. Okay. So, as an immediate benefit, this closes the aforementioned bidirectional information gap in AR language modeling, leading to improved performance. So this is if you have a sequence and you hide one thing in the sequence, you can model both, you can model it or you can guess it given both previous and preceding information. Preceding and post-seeding, is that a word? Before and after. William says, oh my God, I'm learning, thanks. We're all learning. We're all learning together. Every morning I wake up and I'm like, I'm ignorant of so many things, and that's a gift. I get to explore them. Yer says, all probability concepts are more clear to me since I started to study the PyMC3 library. Oh, cool. That's helpful. And Haresh says, are you a PhD? I am. It is in linguistics with a focus in natural language processing and sociolinguistics. And I've talked about my dissertation before on the channel, and I'm not going to do it again because otherwise I'll get sidetracked. However, the artificial symbols like mask used by Bert during pre-training are absent from real data at fine-tuning time, resulting in a pre-trained fine-tuned discrepancy. Okay, so this is what they mean. They mean that the token that you are using to mask never shows up in your vocabulary. Excellent. And that answers the question that I think Andrew had earlier. Yeah, helpful. Moreover, since the predicted tokens are masked in the input, Bert is not able to model the joint probability using the product rule as in AR language modeling. Okay, so you don't, because you're guessing the masked word, you're not given it, you don't know what it is, so you can't learn about its co-occurrence with other words, is what they're saying. But if I remember correctly from the Bert paper, they had some that were masked and some that were just I think only 30% of them were masked. Does that sound right? It was a minute ago when we read this. Yeah. Sroth says, if we see the next word after the word then we want to predict, the word seems to be learning with next words and previous words. I think that's why high directional settings won't work with language models. Bert is not a language model. It's more like a denoising autoencoder. I think it is a denoising autoencoder, but it is also used as a language model would be, so I am comfortable calling it a language model, even though it's not modeling conditional probabilities. For me, what makes a language model is extremely utilitarian. Like, can I plug it into the place where I need a language model in my processing? Unless, specifically does it have conditional probabilities of words? That's me. Yeah. Isn't that overcome by multiple random sampling during training? Yeah, I would think so. But I guess their point about you never see a mask token in real life is, reasonable. Moreover, since the predicted tokens are masked in the input, we did that. In other words, Bert assumes that predicted tokens are independent of each other given the unmasked tokens, which is oversimplified as high-order, long-range dependency is prevalent in natural language. Bert assumes predicted tokens are independent of each other given the unmasked tokens. Okay, so we have 8... we've got let's say we have 8 training samples. Each of them has one masked word. We predict the masked word for each of them, but we don't use the predicted word in the rest of our training. So we don't know the relationship between our predicted words that were masked during training. I think that's what they're saying. Sharath says, a language model has to have generating capabilities, which Bert lacks, I guess. I think you could generate with Bert. I don't know that you could generate, right to left in the normal language generation way. Oh, that's a good question. If I wasn't working on something already for my live coding, I think that could be a fun live coding project. Santhosh says, what is denoising in the paper? I don't know. What does the denoising mean? ICML 2008. Ooh, that is vintage. Yes. No. Tell me what denoising means. Oh, I see. Okay, so the denoising thing means that we've corrupted the input. This is the same terminology that they use in this paper, which says to me that this is in the same sort of academic tradition. So it must be denoising because we introduced the masks, and the masks are introduced noise, and by guessing the words to replace them, that's removing the noise. That's a good question. Thank you. Nicola says, assuming that Bert doesn't use the predicted word for further training, isn't that a good thing? I don't know. I think that's an empirical question. I think one thing that you could do if you use the predicted word for further training is end up with that thing where existing biases are amplified, which we know. So if you have an unbalanced class and then you train models on an unbalanced class, one thing that we know about sort of language models and distributional semantics models is that class imbalance will be exaggerated, which is part of the reason why debiasing in word embeddings is such a big deal, because if you don't do some sort of debiasing, any existing bias will be worse when you apply your model. And I'm trying to remember the citation for that, and I don't off the top of my head, but I do have a kernel on Kaggle that reproduces that paper, so if you're interested. Yeah. Uh, Scott says, I think you have to feed Bert embeddings through a sequence-to-sequence layer to get language generation. Yeah, that makes sense. Yeah. Okay. Good questions. I have forgotten where we are. Okay, so here's what they're talking about, modeling the joint probability. I guess that's true. In other words, Bert assumes the predicted tokens are independent of each other given the unmasked tokens, which is unsimplifying as high-order long-range dependency is prevalent in natural language. I'd have to go back and review the Bert architecture. I don't actually know if they're independent, but I guess I trust these researchers to know what they're talking about. Do I have any updated version of BioBert in XLNet? I don't. Somebody in the comments might. Sarah says, oh, they're talking to DR. Okay. Faced with the pros and cons of existing language pre-training objectives, in this work we propose XLNet, a generalized autoregressive method that leverages the best of both AR language modeling and AE while avoiding their limitations. Oh, so maybe people don't call autoencoders language models? I do. That's me. Again, extremely utilitarian. Firstly, instead of using a fixed forward or backward factorization order, as in conventional AR models, XLNet maximizes the expected log likelihood of a sequence with regard to all possible permutations of the factorization order. Are they shuffling words? What does that mean? Thanks to the permutation operation, the context for each position can consist of tokens from both left and right. In expectation, each position learns to utilize contextual information from all positions, i.e. capturing bidirectional context. Okay. Okay. So there's no... Okay. So in the product, there's no effect of order. Yeah. So the effective order is that you are looking at words at position T given words before that position. Okay. It doesn't matter what order the words before position T are in. So I think what they're doing is they are shuffling all the words, training a language model on words in a shuffled order, shuffling again, training, shuffling again, except they're probably not shuffling. They're stepping through all the possible permutations. Oh, this makes me tired to think about. That's a lot of work. Is that what they're doing? The context for it consists of tokens from both left and right. Yeah, it would. It would if you were doing that. In expectation, each position learns to utilize contextual information from all positions, i.e. capturing bidirectional context. Mobus here says, XLNet is time-consuming. Yeah, sounds like, huh? I think someone did the math and figured out that it took like $285,000 worth of compute to train, which, yikes, that's so much. Secondly, as a generalized AR language model, XLNet does not rely on data corruption. Okay, so you're not removing data, but in language, randomly shuffling words is something that I personally would call corruption. And I know that corruption probably has a specific technical definition here, but if they're doing what I think they're doing, they're still messing with it. They're still doing stuff. Hence, XLNet does not suffer from pre-trained fine-tuned discrepancy that Bert is subject to. Meanwhile, the autoregressive objective also provides a natural way to use the product rule for factorizing the joint probability of the predicted tokens, eliminating the independence assumption made in Bert. Okay, that makes sense because for every token you see all the other tokens in your sequence that you are modeling. Andrew says, like looking at all possible orderings from a bag of words? Yes, this is what I assume that they are doing. Sarath says, assume seed as I like to. What Bert will predict after that? It should be something the model expects after the seed, but that's what we want to model predict, and that's what the model needs to predict. So you would have to be like, I like to mask, and then ask Bert to predict what the thing was that came after that. It is a kind of noise. Yeah. Yer says, they are adding noise. corrupting the output. But I get what they're doing. I understand what they are going for. I don't know. It feels weird to me. It feels like it's ignoring syntax. Okay, let's make sure that they are doing what I think they're doing first. In addition to a novel pre-training objective, XLNet improves architectural designs for pre-training. Inspired by the latest advances in AR language modeling, XLNet integrates the segment recurrence mechanism and relative encoding scheme of Transformer XL, have not read that paper, into pre-training, which empirically improves the performance, especially for tasks involving a longer text sequence. Okay, so they're doing something more efficient with their model architecture that we'll talk about soon, presumably. Naively applying a Transformer XL architecture to permutation-based language modeling does not work because the factorization order is arbitrary and the target is ambiguous. As a solution, we propose to reparameterize the Transformer XL network to remove this ambiguity. Okay, they are definitely assuming that I know what Transformer XL is. I know that it exists, which is about as far as I have gotten with this. So you can't just take your existing architecture and then use it again, because the factorization order is arbitrary, i.e. random, and the target is ambiguous. I don't know what they mean by that. As a solution, we propose to reparameterize the network to remove the ambiguity. Okay, presumably they'll talk more about that when we get there. Empirically, XLNet achieves state-of-the-art in 18 tasks, 7 glue language understanding tasks, 3 reading comprehension tasks, including squad and race, 7 classification tasks, including Yelp and IMDb, and the Clue Web 09B document ranking task. Under a set of fair comparison experiments, XLNet consistently outperforms Bert on multiple benchmarks. Okay. I will point out that since reading, I wrote a blog post a while ago about a paper looking at baselines and showing that you can, if you, let's see, so it was for recommender systems, and the authors fine-tuned some baselines from like 10 years ago and achieved state-of-the-art by continuing to fine-tune. So I am a little bit more leery of model comparisons these days, but I'm assuming that they're going to compare it to the results reported by the Bert authors, which I think is probably fair. I don't know. We'll see. All right. Related work. The idea of permutation-based AR modeling has been explored in 3211, but there are several key differences. All right, 32. JMLR, so neural autoregressive density estimation, very much not a NLP conference. And then masked autoencoder for distribution estimation, ICML. Actually, just okay, so there is an ACL paper here. I'm just going to look at the references. I'm just curious. Preprint, NeurIPS, dataset, Common Crawl, NeurIPS, ACM, ICWCD. I'm not familiar with this conference. Archive, preprint, ICML, ICKM. Never heard of this conference. Preprint. I'm sure these are all fine conferences. I'm just not familiar with them. Preprint, ACL. Okay, one ACL paper so far out of 14. Preprint, NeurIPS, preprint. LDC. This is going to be about a data set. Preprint. Weird preprint. Preprint. VLDB. Endowment. No, another thing I've never heard of. Something wrong with that citation. Preprint. JMLR. NeurIPS, ICLR, preprint, preprint, NeurIPS, IEEE. Okay, so this is not a specifically NLPE. This work is not specifically situated in the NLPE literature, and I think the ACL paper is probably Bert. No, it is not. Okay, so this was a Bert paper. Sorry, the Bert paper was published at NACL, which is an ACL conference. Also, I do not like when people cite preprints when the published paper is available. And I will get you on it if I'm reviewing. I'll write you a little, I'm not going to write a nasty note, but I'm going to be like, hey, this is not the citation for this paper. Incorrect. All right. So people have been doing AR-based modeling, permutation AR modeling. Those paper titles did not seem to me to be focused on language specifically. Previous models are orderless. Oh, interesting. Okay, so it is order aware. Oh, interesting. So I take back what I said about them ignoring order entirely. Previous models are orderless, while XLNet is essentially order aware with positional encodings. Okay. Bert also used positional encodings, and they had like a weird part of the paper where they were like, we compute it with a function instead of counting. This is important for language understanding because a orderless model is degenerated to bag of words lacking basic expressivity. Yes, 10 out of 10, correct. Okay, I'm much more on board with this paper now. The above difference results from the fundamental difference in motivation. Previous models aim to improve density estimation by baking an orderless inductive bias into the model, while XLNet is motivated by enabling AR language models to learn bidirectional context. So I think the difference here is that XLNet is for language. And language is not random in terms of word order, as all of you know as language users. Okay, let's get our math hats on. In this section, we first review and compare the conventional AR language modeling and BERT for language pre-training. Given a text sequence, x1 to xt, AR language modeling performs pre-training by maximizing the likelihood under the forward autoregressive factorization. This one, where h theta x1 through t minus 1 is a context representation produced by neural models, such as RNNs or transformers, and ex denotes the embedding of x. Andrew says, aren't they effectively finding an order that produces the maximum likelihood, which may not be the actual ordering in the training case? I don't know. Hopefully I will after we get through this formula. Okay, so we're maximizing theta, where theta is the log likelihood, log probability of x. So we want to get the most likely text sequence. And we are summing, this one's a summing, the log probabilities of t1 through t, given, so we're looking at the probability of t given everything before that, and we're going through our whole sequence. So if our sequence is I like cars, we're going to do probability of I given everything before it, probability of like given everything before it, probability of cars given everything before it. But we also, okay, no, this is still basic autoregressive functions. And we get that by taking the exponent of the context representations for all of the previous words. Fancy T? Strauss says, BERT is not an autoregressive model, XLNet is. Yeah, BERT is an auto-encoded model, not autoregressive. Fancy T, the embeddings of XT. I don't know what this symbol means. Energy says, I'm scared from this big formula. You and me both, buddy. I would almost always rather have things as code. Okay, these ones I know. I'm looking for a weird looking T. Scroll. I know this is very fast scrolling. Transpose. Okay. Thank you. Very helpful. The worst thing about reading formulas is when there's a symbol you don't know, because they're extremely hard to look up. I used to send screenshots to my friend who was in a math PhD program. I was like, what does this one mean? Nick, help me. And then he left the math PhD program and didn't really want to talk about math anymore. Completely understandable. And I did not want to bother him super much. So, oh, it's called tau. Fascinating. Thank you. Okay, so we have this matrix, which is the model's representation of the sequence before our previous sequence, and then the embedding for our given sequence, and then we flip a Rooney, we transpose them on each other, well, I guess, and then we take the exponent. So this is for the given... So this is for the one that we're looking at as we step through. And then this one is x prime. William says, why are they taking the log of the exponent? So they're taking the log here because they want to maximize the log probability, and that has to do with the like it's easier to minimize if it's a log than if it's the raw probabilities. I believe I remember. Nicholas says this is really stressful to read. That's okay, we're all here together. Okay, and so we're doing the same thing given x prime. What does that mean? Where are we getting this from? Summing over... so this must be everything in our vocabulary, yeah? Okay, so this is just an English T. Except it's not serif for some reason, unlike the rest of the fonts. So that's helpful. Andrew says, easier to sum logs than multiply probabilities. Oh, yeah, that makes sense. Santosh says, autoencoding models means you will use transformer network. So this is not an autoencoded model. This paper is about an autoregressive model. But yes, the autoencoding model did use transformers. Okay. Oh, Andrew says, normalizing. Okay. So this is normalizing over all of the words in our vocabulary, I think. Yer says, the log helps to make distances equal, numerator versus denominator, when you are using fractions. Okay. Helpful. I know somebody definitely stood in front of a whiteboard and pointed at something and told me the reason why we use the log when we do probabilities and maximum likelihood explanation. And I think I can even remember the class. It was like 11:30. It was right before lunch. I was super hungry and it just went very quickly over my head. Oh, Andrew says the denominator is normalizing the sum to 1. Okay. I got you. So now so this means that we're making sure that it's a probability. Is what I'm getting there. How do I says, converting something to log makes it more Gaussian, doesn't it? Does it matter here? It can, and I don't think that's the reason we use it here. Nicholas says, so what does the theta function mean? So this whole bit is the context representation that the neural model makes, the transformer or the RNN or whatever it is that you're using. So this is just a matrix that you pop out of your model. And William says, is it the word over all the words that came before? Yeah, basically. Yep. Okay. Which I think makes sense to me. I think I'm picking up what they're putting down. I don't know why there's a comma here. Is that a math thing or is that a typo? I don't know. So there's a comma at the end. Andrew says, if you sum a lot of small probabilities, you lose resolution. Converting it to log helps, I think. That also makes sense. Okay. In comparison, Bert is based on denoising autoencoding. Specifically, for text sequence X, Bert first constructs a corrupted version X hat by randomly setting a portion, e.g. 15%, of tokens in X to a special symbol, mask. Let the mask tokens be X bar. Is that what you say it? Alekin says the comment is a math thing. Okay, helpful. The training objective is to reconstruct X flat hat. I don't know what that's called. From X hat. I definitely did know what it was called. Does it? Oh, it's like punctuation before you continue. Gotcha. Oh, you're supposed to read this in a sentence? Where H theta, etc., etc. Oh, okay. I don't think I could read that as a single sentence. Maybe in 5 years after I've been reading similar formulas for a really long time. Very helpful. X hat, X caret. So X hat and then X caret. Okay, we can do that. Shubhan says log is a monotonic function. Taking log makes multiplicative functions into addition, and then taking derivatives is easy, unlike usual UV rule for derivatives. I got it right, haha. I'm going to call this X flat hat and this one X hat, and that's just what I'm going to call them for right now, and if that's confusing, I apologize. Okay, so we're going to take, we're maximizing the log likelihood of X, given X caret, which is proportional to summing over, it is X hat following ELSS notation. I've never heard of that. When I was taking, we all were studying math notation, I was studying syntax. Like in human languages. Okay. MT equals 1 indicates XT is masked. Okay, so this is 1 when it is masked, and otherwise it's 0, I'm guessing? So, we're looking at the log probability of T given X hat, where X is a corrupted version. Okay, so we're looking at we're given the corrupted version, and we're trying to find the maximum, and then we're finding the log probability of X sub T multiplied by 1 when it is masked. And that is the same as summing over the log. Oh, if it weren't a log, we couldn't sum. We'd have to do the product. Makes sense now. And for that, we take the exponent of H theta is a transformer that maps a length T text sequence X into a sequence of hidden vectors, H theta X, H theta X1, H theta X2, etc. Transposed on the embedding, and then divided by going through all of the vocabulary terms, so normalizing. So the difference between these two things is that instead of trying to guess the next sequence, we are trying to guess the masked sequence when it is masked, and if it is not masked, then we ignore it. That's what I'm getting here. Ryan says, have been driving so couldn't chime in earlier. Microsoft new model is called Mass. Tried XLNet, Bert Base, and large, and GPT-2 small on Jigsaw. XLNet wasn't that good and was bigger than Bert large. Interesting. Andrew says, no, I know a lot more of the math stuff, and I'm still struggling, so I commend you all. William says, I was studying creative writing. Oh, how I'm out of my comfort zone. Fun fact, my undergraduate degree was in linguistics and English literature. Ask me about Beowulf. Don't. It's been a minute. And Swaraj recommends Elements of Statistical Learning, which I hear is a very good textbook. And when I tried to read it, there were a lot of symbols when I didn't know what they meant, and I was confused and scared and stopped reading. Alakin says, what is X prime? I am assuming that X prime is each of the words in the vocabulary? I'm going to have to wait a while for the stream to catch up with me. That's what I'm assuming. The pros and cons of the two pre-training objectives are compared in the following aspects. Okay, independence assumption. As emphasized by the approximately equal sign in equation 2, Bert factorizes the joint conditional probability, P bar, given P hat, based on an independence assumption that all masked tokens are separately reconstructed. In comparison, the AR language modeling objective factorizes P theta X, which was the probability of, it's the thing that we're trying to get, using the product rule that holds universally without such an independence association. And some clarification. So it just means look at all the things and then sum for the denominator. So here X prime is standing in for all of the X's in our text sequence that we're modeling, or in our total vocabulary of words. I don't know which one that is. See, this would be trivial if I had the code in front of me, and I know that they have the code, but people don't usually publish the code as the paper. Okay. Input noise. The input to Bert contains artificial symbols like mask that never occur in downstream tasks, which creates a pre-trained fine-tuned discrepancy. Replacing mask with original tokens as in 10 does not solve the problem because original tokens can only be used with a small probability. Otherwise, equation 2 would be trivial to optimize. In comparison, AR language modeling does not rely on any input corruption and does not suffer from this issue. And some clarification. So it is summing over the total vocabulary. Thank you. Very helpful. And then, Mohammed asks, what does mask mean exactly? So the way that Bert works is that you have a text sequence and you replace some of those words with this sequence mask, and you're trying to guess what those words are given the mask token and the rest of the words in the sequence. So this is something that you are feeding into the model as you're training it, and then it never sees later on because this isn't a token in English, if that makes sense. Ryan says, not sure if they mentioned this somewhere, but I'm thinking if they use the sine wave positional encoding, that might cause some ambiguity in the order of words. Yeah, so they mentioned it very briefly that they do use positional encoding, and that they're not using an orderless model, even though previous models are orderless, but I'm not entirely sure how that's going to work. Presumably they will talk about it more when they talk about their, it's very pretty, their very nice model architecture diagrams. Context dependency. The AR representation is only conditional on tokens up to position T, while Bert representation has access to contextual information on both sides. As a result, the Bert objective allows the model to be pre-trained to better capture bidirectional context. So they're saying that the problems with Bert are that it assumes that all of the mask tokens are independent of each other. Also, the fact that there are tokens masked that you're training on, but the benefit is that instead of just looking backwards, you have information about the entire text sequence. So that's where I think I'm going to wrap it up, because I don't think I have, oh yeah, it's 10. I don't think I have time to keep going. I got a lot to do today. Yeah, I am really interested to see how they're going to combine both randomly shuffling words and also positional encoding in a way that makes sense to me. But I think it's an interesting paper. Very much more of a machine learning than an NLP paper, even though they are working on language. And I am glad that they were like, hey, sometimes in language, order is important, because they're correct, and it is. And that is good to hear machine learning researchers talking about. All right. Well, thank you for joining, everybody. That is going to be it for this week. George says, what does ambiguity mean in this context? Oh, I know they mentioned it. Well, I think we will get to it later on when they talk about it a little bit more. I don't know precisely what they mean by it in this context either. So we're together in that. All right. If you're in the US, enjoy your holiday. I know Canada Day was also this week, so I guess happy Canada Day. And I will not be back on Friday. I will be out in the world doing other things that aren't work. But we will be back on next Wednesday, and then also the Friday after that. And we do have another SQL summer camp coming up, so July 16th through 18th. So if you come on the 17th for the reading group, you will instead learn about SQL. So just be warned, and we will be picking up the week after that. Niklas says, what's on Friday? The 4th and 5th are holidays in the United States, so I'm going on holiday. Yeah. It would be a lot more work just to get here without your help. I appreciate y'all's help, because again, looking at mathematical symbols, really difficult. Okay, I'm going to see you guys on next Wednesday. I'll talk to you then. Bye.